Okay, let's I accidentally did this one by mistake. I had some questions left on the previous section I didn't realize. Okay, so yeah, some graph and stuff here. Let's have a look. Window. Okay, so we'll start off with e power x minus 1 over x. Okay, let's graph that. So that looks like a 1 from the graph. And then let's have a look at the next one, which is x sine 1 over x. That looks like a 0. And then the next one is x minus 1 over 1 minus cos pi x. Huh? Oh, it's crashed. Does this weird thing sometimes. No, sorry. I missed the bracket. Oh, it's towards 1. So that looks like it could be a 0. X minus 1 e power x minus 1 minus 1. Ooh. Zero 0.59, 0.6. What could that be? It's going to have an e involved in it. Possibly 1. No, 1 over e. I don't know. I don't know. I'm going to say about 0.6, but I'm not sure what it's going to be. Oh, no, sorry. This is going towards 1. So that looks like a 1. Okay, the next one, log x, and then this is x minus 1 squared. That looks like a 0. No, it's towards 1 again. Sorry. So that, yeah, that's still a 0. And then 1 plus cos x over sine x towards pi. Clean that up. Like a 0. And then 1 over sine x minus 1 over x towards 0. Oy, tan x power x towards positive 0. What the? Yeah. Pi over 2, I'm guessing. Total guess here, pi over 2. Log x over sine x. Towards 0. Minus infinity. And then lastly, e power x minus e power minus x towards 0. 2. Yeah, makes sense. Right. L'Hopital's rule for the first one we can use. So up there, just do it roughly. it would be ex at 0, which is 1, so that matches up. Okay. And then here the next one. 0. Problem is this blooming sine 1 over x coordinates. Oh, squeeze theorem, I think will be best here. So we know that this will be between it will be between minus x, because this has to be at least minus 1. And it has to be less than plus x as x goes to 0. So therefore the limit has to be squeezed to 0. Okay, so good. L'Hopital's 1. So the derivative is 1 over pi sine pi x when x goes to 1. So sine pi is 0. No, when x goes to 1. Sine pi is 0. Can I not use L'Hopital's? 1 minus cos pi is 2. Yeah. Oh yeah, there's no need for a special rule here because it's just, yeah, just sub in, it's just going to be 1 minus 1 over 2, which is 0. So that's correct. Okay. One, yeah, that's L'Hopital's. So that would be ex again, 1. Which is e. So I think I must have looked incorrectly on the graph. E power. No, I must be. Can I not use no? Oh, that's a 0. Okay, derivative. Oh, sorry. Okay, forgot the power. So that would be E0, which is 1. So that's correct as well. Okay. 1. That is going to 0. But that's also going to 0. So L'Hopital for sure. 2 x minus 1 over 1 over x, which equals 2x times x minus 1, but when x is 1, so that's 0. Good, that's correct. Cos pi is minus 1. So there's nothing special there. It's just 1 minus 1 over, oh no, it's over 0. So, okay, L'Hopital. So that would be sine x over cos x, which equals tan x. Isn't it? Minus sine x over cos x, which is tan x, which is 0. Okay. So this one here is 1 over sine x minus 1 over x, which is x minus sine x over x sine x. And that's going to be equivalent to x minus x over x squared as x goes to 0, which is equal to 0, or you could use L'Hopital's. Okay, This one here is a tricky one. We know from earlier that the limit as x goes to 0 of xx is 1. So therefore, it's just tan of 1, which equals pi over 2. Would that be good enough? I don't know. That's heading to minus infinity. That's heading to 0. So this would be the same as the limit as x goes to 0 of log x over x. That's going to 0. This one I'm not sure because I can't use L'Hopital, so let me come back to it. This one here is definitely L'Hopital. It's going to be EX plus EX over 1 when x is 0. So that's the 2. So that's correct. And that 0 was correct, and that 0 was correct. So really, it's just this guy here, either way to think about it. Sine x. What could I do? Maybe I could change, see, because tan is sine over cos. That help? Would that help? If I calculate it with an e, that doesn't really help because that's log over sine. How to do that last one? I have sine going to 0. I mean, I could change it into limit as x goes to 0, sine x behaving like x. So it's 1 over x times log x. I guess, yeah, and this one here is going towards positive infinity, and this one here is going towards minus infinity. So the net result is minus infinity. I guess it'll do. So 1, 1, 0, 0, 0, 0, 1, 1, 0, 0, 0, 0, 0, 0, pi over 2, pi over 2. Sorry, I wrote 1 here. Tan 1 is not pi over 2. It just looks close to pi over 2. So that guess here was a nice try, Stephen, but a bad guess. Tan 1 is equal to 1.557, which is actually not pi over 2. It's 3.11 over 2. So yeah, okay. It was I thought it was a solid guess, but it's not actually pi over 2. It just looks like it. So the correct answer is 1.557. So that's right. That was a guess. I took a guess, but not quite that. minus infinity, and 2 and 2. So I think the one I just want to draw attention to is that guy there. That's what it should be, tan 1. Okay, that is up to 405 done, and that's the exercise complete.